Our GPS Lesson 8 assignment was to add an SSD 1306 OLED display to our existing project. Aside from the SSD 1306 details, the program is relatively the same as Lesson 7. The limited space on the OLED does require that we cut some of the data from our report. One change in this program is a move away from discrete variables towards a data dictionary. I don't recall Paul explaining the need for the dictionary, but in the spirit of future compatibility, I have started to use a dictionary to store the GPS data. Let's have a look at the code. As usual, our program starts with imports. Because we're using the SSD 1306 OLED display, we add I2C and SSD 1306_I2C to the list of imports from Lesson 7. We also need to add OLED SDA and SCL pins to our pin declarations. As we did in previous lessons, we declare the objects used in this code: fixed status, UART1 transmit and receive, and the GPS object. We declare our variables on lines 29 to 48. Many variables are carried over from Lesson 7. Some Lesson 7 variables are missing because they now appear in the dictionary. Others have been eliminated because there's no room to report them on the OLED. New variables are GPS data is the data dictionary which will hold the GPS results. HB0 and HB1 are the core 0 and core 1 heartbeat indicators, which will show core activity on the OLED. OLED pixel height and OLED pixel width are self-explanatory, and title will be displayed on the top line of the OLED. And we configure the OLED on lines 53 and 54. Lines 59 to 73 configure the fixed status ISR as we have done in previous lessons. The fixed status ISR is called every time the GPS module LED blinks. The GottaFix variable tracks whether we have a fix or not based on the period of that blinking. The only changes to the read GPS on core 1 function are the removal of the print statements, which reported program activity. Those messages now appear on the OLED, and the addition of HB1, a heartbeat which will be displayed on the OLED to confirm that core 1 is still running. HB1 alternates between 0 and 1 every second. The PMTK314 command, which ensures that the GPS module transmits sentences with a 1 in the command line, has not changed. But lines 132 to 135 are new. They clear the OLED, display the program title in the top line, and the starting core 1 message on line 16 of the OLED. Line 140 is also new. It sets the core 0 heartbeat timer to the current time. Lines 141 and 142 are unchanged from previous versions. There are a few small changes to the main loop. Discrete variables were removed in favor of the GPS data dictionary, and printing to the shell has been replaced with messages on the OLED. The core 0 heartbeat was also added to the main loop. Print statements have been removed from the except clause in favor of OLED messages. Aside from that, the program hasn't changed. Here's how it works. The program monitors the period of the GPS fix LED. When the period is greater than 10 seconds, we have a fix, and we start to parse and report the GPS data. Notice the core 0 and core 1 heartbeat indicators and the fix indicator on the bottom line of the OLED. And the program comes to an orderly finish when the user presses Ctrl-C. Well, that's it for this assignment. Any and all comments are welcome. Don't forget to like or dislike the video before you go. And feel free to subscribe. Don't forget the notification bell. We'll talk to you next time.